before going for the real-time projects and cleaning the data therein, I have arranged some small pieces of data so that you will understand the cleaning process here, and I will share this to all of you so that you can also make hands-on practice on that small pieces of data. Then we will go for the bigger data structure, because the concept is very similar. Anomalies may be many ways it may come, but the concept lies in the same one. Okay, so let's start then. So to clean the data, first of all, let us import the data, and you must be knowing what are the syntax for importing the data. Do you remember all these things? Because data may come in any form. It may be in Excel format, it may be in CSV format, text format, XML format, JSON format, and many other RDBMS data sets may be there. So you need to import the libraries as well, and the data may be from SPSS, Stata, SAS, and so on. So here I have taken a small CSV file, stdclean.csv, and I am now going to import the data here. Okay, so now I have stored the data which is present in stdclean.csv, and I have stored it in data1. This is our data frame or the data set, you can tell, and let me show it to you. See, it is a very small piece of data, very small. So what is therein? There are some fields like role, name, age, address, and CGPA. Clearly understood that it is a student's data and has some fields like this, columns like this, and there are how many records? Only 9 records. Okay. And from this, it will be difficult for you to guess where there is blank, because whenever there will be blank, it will be notified as NA by R. In the actual data set, there will be blank, but whenever it is imported to R, I told you that it will be identified as NA. So you will see many NAs if there exists any. So it will be converted to NA and it will be shown here. But NA will be lost somewhere because you won't find it properly where the NA is. As because there is a very small piece of data, you can very easily identify here and here. But to guess that whether there is some NA or not, let me view it in the tabular manner. You will actually get to know that there is no data here. So this is the data and we are viewing in the tabular format here. So you can see that there is no data. So NA is in faded, that means there is no data here. So actually while entering the data, I have made it blank. So let me show you the CSV file in text format so that you can better understand. When I have created the CSV file, where is that? stdclean. This one actually I have created with Notepad, and you can see it here. This data. So what I have done in the first line, I have just mentioned the headers, the column names, role, comma, name, comma, age, comma, address, comma, CGPA. So here I will not make any mistake, because if I will make anything blank, then it will not take it as a column name, so it will just remove it. It will just omit it. But thing is that if there will be mismatch in the further forthcoming rows, it will just show errors. It cannot be accommodated properly. So now you see in the first row, everything is present. How many columns are there? 1, 2, 3, 4, 5. So you will see that in the first row, 5 values are there. In the second one, you see 102, then Gita, then 21, then Kurta, and comma, there is nothing. So that means it needs a value, but there is no value here. But there is a comma here in order to identify that there is a value needed here. Then in the third row, 5 data is there. Fourth row, 104, comma, Rita, comma, then nothing, then I have given another comma, so that in order to make it understand that, okay, there is a blank. There is nothing over here. Okay. Then Barampur, then 9. So, like this, I have created this data. So, CSV data, text data, they can be very easily created like this with the help of Notepad. Understood this data? How I have created this one? So, if I'll mention again, that means here, not here. I will, yeah, here I will omit this one. Okay. Now you see, there within this pairs of commas, there is no value here. So another NA will be created. Now if I'll save it, close it, and import it again in R. So let me close it here again, import this again, and see the data. You see, there is a blank here. There is a blank here. Okay. And if you view it in data 1, view it to this, here you can get there is a blank here and it is not identified as any. To your surprise, it is not identified as any. Okay. Now let us see that whether it is identified through functions or not. Let me see. Am I audible to all of you?
Yes, ma'am.
Oh, okay. So just tell, sometimes whenever I'm asking this or asking you any question, just tell yes, no, something like that, so that I'll understand that you're all listening to me. Otherwise, I will think that, okay, you have all left or you are not listening. Okay. So let us find out the missing value. So how to find out the missing value? Is.na, that is a function which will show wherever there is na or no na. So whenever is.na is true for any data present in this data set, it will write false. It is not present, it will write false. If there will be na, it will write true. So let us see. Okay. So in these two cases only, here and here, in these two cases only, the value is true, but not in this case. It is giving false because it is taking a null string, and null string is not same as na. Null string is not same as na. So what you need to do? You need to, I told you that whenever there is a missing value can be of many forms. Like it may be completely blank, it may be null string, or a string where unspecified, unwanted, or not specified, or not available. Strings are written like that. But it actually means that there is no data here. So you need to replace it with this na. So for that, what you need to do, I will tell you further. So let me go back to this particular page and just omit this. And what I can do, I can just replace this null string, wherever there is null string, I will replace it with na. So how to replace it with na, I will tell you. Okay. So now, what I will do now, I am going to make some arrangements for the importing of data, then data, view data, then missing values, is.na this. Okay. So now I will replace it, replace the values wherever there is null string with na. So let me do it for you. For that, let me recall the library. And okay, data is missing node with no default. Okay. So first you have to write data 1 there. Yeah. So what will happen? So whenever there is blank, it is taking it as a false. Okay, it is not considering it as an na. So now what I'll do, I will with a function replace with NA, I will just replace this null string wherever it is found, I will replace it with NA value. So that now if I'll show is.na, is.na of data1, now you see, again it is telling false. Okay, let me count on that. So table is.na of data1, which will show you the non-blank values, count of non-blank values. So you will take that false 43 and true. Oh, okay. So what I have done here, replace with NA. This is showing me with NA, but I haven't replaced the data one with that. So let me select. Then it will show true here. Yes. Now there is three NAs here in the data, and when you count it with table function, it will show true as 3. So that means 3 NAs are there. So one thing, two things here is very clear. So whenever there is a blank in the entire database, by default at the entry label there is blank. So R will automatically understand that okay, there is a blank over here. There is an NA value here. But when there is a null string or unspecified or something like that, then it will not understand it as a NA value. It will understand that okay, there's some value is present. But actually, logically, it is a NA value, right? So that we have discussed in the previous class, correct? So in that case, what I will do, I will first replace all these kinds of values wherever it is found. So I found it in address field. So in address, wherever there is null string, list out all those things and replace all those value in the address field which is null string with NA. So replace with NA function will replace all these values which are assumed, which is logically the not available values to actual NA values. And replace with NA function will convert this, but it will not reflect in the main data source. So whatever value will have with the NA values, that must be stored in the original data set so that it will have the NA value. Okay. So now data 1 contains all the required NA values in the entire data set. But for using this replace with NA function, you must import this NANIR. Okay. This library you have to import. Otherwise this function will not be available. Okay. So now you can see that if you simply write is.na, it will show you the list of false and trues. But if you want to have a count on that, count on missing values, count of NA values, then is.na of table. You can also do it with sum. Okay. So if you want to just count the number of NA values, because table will give number of false and number of trues, but sum will actually give the number of true values whenever it is true. So this is the correct method. So this particular treatment helps in converting all your undesired data. All your undesired data means, suppose I will show you in real-time demonstration, in real-time project, I will show you that how this data is having lot of anomalies. So there also you need to convert it to NA format in order to get rid of them. Okay. So now by this time we have identified the NAs and we have got the count of NAs. Now what we will do? We will do the missing value treatment. So how many ways we can do the missing value treatment? There are two ways. One is removal of the missing values. Another is replacement of the missing value. So how to remove the missing values, you see? So whenever you are doing the treatment of the missing values, you take a backup of the original data set. Because when if you do not take this backup and you get rid of the missing value, suppose you want to remove the values and something goes incorrect in that, something goes wrong in that, then you have to collect the data from the beginning. You have to collect the data from the beginning and do all the treatments that you have done before that. Okay, so you must take a backup of that. So I'm taking the backup of that safe. For safe side, I'm taking the backup of that. So data 2 is equal to data 1. Now let's show this data 2 whether it is properly collected. Yes, it is having covered. Okay. Now in the first step, first method, I will remove the rows containing NAs. Then how many rows are containing NAs? This one is the row, this one is the row, and this one is the row. This one is. So 3 rows are there which will contain the NA. So now out of 9 rows, if I go for removing all these NAs, so I will get rid of all these 3 rows, all the data which is contained in the 3 rows. So how to do that? So na.omit of data 1 will show you all the data without the NAs, all the records without the NAs, but it will not reflect. It will not be reflected in the original data set. It will just show you the number of records, all the records without the without the records having NA values. So it will just be like that. But if you want to reflect these changes to data 1, you must assign it. So I will assign it. Now I will show the data 1. So it will be like this. But now I don't want to do that thing because it has one or more not available, but other values are there, other data is there. So I must replace it with proper alternative. I don't want to remove it. So we'll go for the next method, that is replacement of NA values. So let me clear the screen. Now for that I need the entire data back again. So as because I have stored it in data 2, so I will assign it to data 1 now. And let me show you. Yeah, now data came. Now see, data 1 of age is having an NA, data 1 of CGP is having an NA, and data 1 of address is having an NA. Okay. So let me do the treatment for the columns. First I will do the treatment for age column. So let me see that how many data is NA here. So here it is true, the fourth one. So what I will do, I will just replace as because there is only one NA value, so I will just replace it with the most frequently occurring ages. So I want most frequently occurring age means most frequently occurring value means what I mean. I can replace it with mean, median, maximum, minimum, etc. But I want to replace it with the most frequently occurring age. So what does that mean? With which value I want to replace it? Yes?
Use the mode function.
Exactly, mode, not mode function.
Mode.
I need to replace it with mode. There is no mode function. Just remember properly, there is no mode function. So how to calculate the mode of this age? Okay. If I go for mode of this age, so let me find out how to see the mode of age. Let me have a vector one, just a demonstration, vec one, and I will have some values like 12, 12, 23, 24, 25, 26, 26, 26, then 29. These are the values. Now I want to find out the mode of this. Now you see how to calculate the frequency of each item. Which function will help us to calculate the frequency? Can anyone tell? So many times I have discussed. Which function gives us the frequency of items?
Table.
Yes, yes, very good. Table function. So if I write table of vec1. Oh, vec1 I haven't created. Okay. Yeah. Now see. what it is showing? It is showing the frequency of each item. 12 comes twice, 23 once, 24 once, 25 once, 26 three times, 29 once. So now which one will be the mode? 26 will be the mode, correct? Okay, now how to get it? I don't have a mode function, so how to get 26? So what I will do, I will just sort this entire representation. So sort table of take 1. So you see what will happen here. So what is happening? All the values, values are arranged depending upon the ascending order of the frequency, right? That means lowest first, highest at the last, correct? Now, but I want the mode. That means I want this one to be the first one. So what I will do, in case of sort function, I will just use the decreasing equal to true. So what it will give me? It will give me the reverse. That means it will arrange it in descending order of frequency. So 3 comes first. Okay? Are you getting or not? But what I want? I want to get the 3 or I want to get 26. I want to get 26. Achha. Let us first take the first one. So if I'll take 1, then okay, 26 comes. Because the first value. This you know, indexing. Out of the entire data, I will take the first one. That will come by index position, that is 1 I have given. But I don't want both. I want only 26 because 26 is the mode. Because it occurs 3 times. So how to get that? With the function names. So names of this will give you 26. Okay, now you got the first value, first number, but see the difference. Even if it is a number, it is shown in the character format because names convert it to do so. Name orders it to do so. So that's why whatever values you will get in names, because names contains call names, row names, these are the parameters there. So whenever you go use the function names to collect this 26, it will automatically convert it to character format. But I don't want it integer format. So what I'll do? I will do the coercion as dot integer of this. Okay. I will get 26. You see, logically you think and go on adding the function and you'll get the proper output. Now, is the mode calculation? This is the mode.
Madam?
Okay. Yes.
Madam, if we omit that names, then what will happen, ma'am? Just check.
It will show you both 26 and 3. See, up to this point.
Madam, we will include as integer, but we will omit that name. It will show error or what, ma'am?
No. First of all, why you have given as dot integer? Because names is giving only 26. If you do not mention names function, it will give both 26 and 3, which is not desired. I don't need 3 at all. Do you need it?
No,
you don't need it, need the both. So how to get the 26? Because 26, 12, these are the numbers. So you need the numbers only. You need the numbers only. So you have to get the number first, get the heading of this mode, the frequency values. So these are the names of these tables. So whenever you get the names, it will come in character format and you need to convert it back to integer format. Then only you will get 26. So now 26 is coming as a mode. Okay. So you can do one thing. You can just make a function to calculate the mode. So what what function you can do here? You can write a function, let's say get mode. Get mode is a function name, and you write function here, and within that you provide some values here. Let's say any object whose function, whose mode you want to calculate. Okay, now inside that what you will write? You will just write mode equal to as dot integer of names of sort of table of object, whatever object it is getting, then comma decreasing equal to true, and out of that then it's the first value. Okay, and after calculating this mode you must return the mode to that. Okay, so this is a function you can calculate the whatever value, whatever set of value will be applied to this, it will just calculate the mode. So suppose I will write mode mvec, or let's say mode vec1. Suppose I want to calculate this, so I will just write mode vec1 is equal to get mode of vec1. Okay, vec1 is already assigned. Now I will just register this one, and now I'll calculate and print. So semicolon mode vec1. So automatically it will take, it is taking 26. Okay. So whenever you need to find, you just make a user defined function. You know how to create the user defined function. So you know how to create the mode. So you just take it, make a function get mode, and it can apply it anywhere wherever there is a mode requirement. So that you don't need to, for let's say there are 24 columns, and for each column you need to calculate the mode. So what I will do? You just calculate the mode with the function and call it every time. You make a for loop where how many number of columns are there. For each column, just calculate the mode and display. At one go, you can calculate all the modes, right? Here. So these are small techniques that you need to apply whenever you are doing the data analysis. Okay, data cleaning. So this part I have created for demonstration. You may omit this one, and whatever material I will give you, that this part is not there, so you can add of your own. Okay. Now what I will do? I will replace it with the age. Replace the age with mode age. So what I will do? Mode age I will calculate. Again I have to write the entire thing here. You see, I am writing entire thing. So instead of writing the entire thing, what I will write? I will write mode is equal to get mode data1 of data1 $age. Okay. Let's see. Let me show it here. Mode age 56. Okay. Clearly, data1, if you can show here, so clearly 56 is the mode age here, and it is very easily calculated by this get mode function. You have already designed it, and instead of writing the entire statement like this, which may create error, once you will test it, and many a times you can use it. Isn't it fascinating? This is the benefit of using the user-defined function. Okay. So I have calculated the mode age. Now I'll replace the age value wherever there is NA in age, it will be
Hello, ma'am.
replaced with mode age. Yes,
Hello,
anyone
ma'am.
want to ask me anything?
Yes, ma'am. Please scroll the user-defined function that we have created. I want to take screenshot.
You want to write or
No, I just
screenshot?
want to take a screenshot. Yes.
Yeah. Okay, let me, yeah, take a screenshot. See,
Okay, ma'am.
you take the screenshot, but you try it first at your own end.
Yeah, yeah.
If you
That's right.
can't do it on your own, then only you refer this one. Otherwise, your programming ability will be declined. So you just try it on your own, then you type it. Okay. So what I will do now, I will use the function replace, and what I need to replace, data1 of age, and which data1 of age I want to replace, is.na of data1 of age, that means wherever there is na in age, and with whom I want to replace, mode of age, mode age value that I have already calculated with the getMode function. Okay. Now this entire data set, what I will get after replacement, I will assign it to data1 of age, so that my data1 age will not have any NAs anymore. Now similarly, I will do the same thing with, let's say I want to do the same thing. Is there any double values or mode values there? Okay, 8 is there. So I can also do it with mode of CGPA, but I think I will use another function, that is mean. So mean of data1 of CGPA, with that I will replace the CGPA value. So replace function within parentheses data1 of CGPA, wherever is.na of data1 of CGPA, then it will be replaced by mean of data1 of CGPA. But what will happen, as because there is an NA, so whenever you will calculate the mean function, let me show you why I have taken this na.rm is equal to true. So what is the mean of mean function is to calculate the mean of the data. So now I want to calculate the mean of data1 $CGPA. So what should be the value? You see, 8.5, 7.5. How to calculate? I will add up everything and divide by 9, right? Is the way to calculate the arithmetic mean, right?
Yes, ma'am.
Yes. But as because, let me do it for you. So what it is showing? See, mean of data1 of CGPA. Why it is showing NA? Because if your column contains at least one NA, it will not be able to add up everything and divide with anything. It cannot be added because NA is not a type of numeric type, so that it can be added up or it can be divided. No arithmetic operation would be possible. So you need to remove NA. So whenever you go for calculation of mean, you just remove NA. So how to remove NA from that? So NA.rm equal to true. Then you show. Yes, now it is 8.5. So it will calculate the mean but without the NAs. Got it? So whenever you wish to use the mean function, do not forget to use this na.rm equal to 2, because this mean function will result into again NA. So it will not be replaced. You are replacing the NA value with another NA value. So it will not get replaced. So whenever you are going for mean function, make sure that you provide this na.rm equal to true. Okay, understood this one?
Yes, ma'am.
Yes.
Okay. Now let us see the data one. I have already replaced the two NAs of age and CGPA. the CGPA is replaced by the second CGPA was there. So CGPA is replaced by the mean value of CGPA, that is 8.5, and age is replaced by the mode value of age, that is 56. But what about the address? There is one address here, and how to get rid of this NA here in the address field? So what I will do, I will make a static replacement here. So I'll write data1 dollar address is assigned the value, that means replace data1 dollar address comma wherever is dot na, that means wherever there is an na in the address, data1 dollar address, and it is replaced by, I will randomly write Kotak. Let me replace it with a static value, that is Kotak. Use it. What happened? Again, cache error. R MySQL. Oh. Restarting. Why again R MySQL is required? Loading required package. Yeah, no. Okay. So now let us see the data1, which is free of everything, free of all NAs. You see, everything is now okay. So data is now free of the missing values. Okay. Now let us go for the checking of duplicate records. So I told you duplicated is the function. Just remember the functions so that you can make your way out. Okay. So whenever there is just by looking to the data itself, just tell me that whether there is some duplicate records or not. Is there any duplicate records?
Yes.
Yes, ma'am.
Which records are duplicated?
Row 5 and 6 and 7. No, 6, 7.
Only 6 and 7. If it fully duplicated records are 6 and 7. Because 5 have different CGPA.
Yes, ma'am.
Okay. So 6 and 7 are fully duplicated. You see, every value is there. So I need to get the sum of, if it is a big database, so I need to show that how many duplicate record is present. So one more duplicated record is present. So one it will keep, one will be duplicate of that. So as because there is 2. Okay. So now how to get rid of the duplicated records? Use the function unique or you use the function distinct. Okay. Now let us use the function unique. You see, if you use the function unique, it will just get rid of that 7th record. You see, 7th record is not there now. So we'll get all the unique records. Unique record means all the values will come, but only if whenever all the values in all columns is duplicated, that record will be missed only. Okay. It will not show any other facility, but let us go for distinct function. So what facility it will give? Now library deployer is there. We have to import it in order to use the distinct function. Deployer function, deployer library has to be imported to use the distinct function, because distinct function is not present in the base R library. It is present in the deployer library. Deployer is a very popular library for data manipulations. So you use the distinct function and you apply distinct keyword. So now you see it will also do the same thing. But can you mark any difference between these two? I'm just removing everything. I'm showing the unique records with unique function. This is the result of unique function, and this is the result of distinct function. Can you identify where the difference is there?
Unique function, there are 9 data sets, and distinct function, there are 8 data sets are there.
8 records. So that means what it is doing, it is omitting it from the data set, it is displaying it, but actually the 7th record is present in the memory. Okay, it is making it blank, not showing it here, but the memory is reserved. But in case of distinct, that memory is cleared and it is getting refreshed. So there are 8 records now. That is one difference. Okay. First difference is that unique is present in the base library, distinct is present in the deploy library. Second is the memory is not cleared, cache memory is not cleared. Here the cache memory is cleared. One more difference is that you can get the individual column wise data. That means you want to get rid of the duplicates in columns also. That means suppose roll number is the unique roll number you should represent. That means you see there are 2 roll numbers here, or if you get the main data, let me show the main data here. Data 1. So in the main data, you see the clear duplicates are these 2. But you see that in roll number there are 3 105s are there. 3 105. So if I want to show only 1 105 in roll number, so I must get the entire data set by role, by distinct roles. So column wise duplicates can be removed also by distinct method. So how to do that? So the structure is, so the syntax is distinct, then first provide the data 1, then comma the column name, suppose roll number, and dot keep underscore all equal to true. So why this dot keep underscore equal to true? So this will make all the records, all the columns present. It will remove the duplicates from roll column and display, but it will keep all the columns. Let me show it. It will keep all the columns. Roll number, name, age, address, everything is displayed. But if I write, see, and in roll number only 1 105 is there. So total 7 number of rows are there. All other 2 roll number which are not, which are duplicates of the first 105, they are just removed. They are removed from the series. And it will keep the first one. It will keep the first one. Okay. Now, if I'll make distinct role but keep all will be equal to false, I'll make dot keep underscore all equal to false. Then what will happen? Only the roll number column will be displayed. Okay. So understood the difference between dot keep underscore all true, dot keep underscore all false. Understood?
Yes, ma'am. Yes, ma'am.
Okay. So similarly, you can also see that name wise, if you have duplicate names here, then name wise also you can see the distinct records. See, Gita is created many times. So that is removed. Name wise. Similarly, you have Katak, in address you have duplicates. So in address, if you see, only one Katak is present. Okay, so like this you can take. And be sure that if you want to keep all the records or not. So this will just show you the distinct records or the unique records. But the data itself is not. If you will show the data, it will just contain all the duplicates. So if you want to get rid of the duplicates, you must assign whichever will be best suiting you, that you assign to data 1, so that your data will be free of duplicated records. Okay? Understood? Is it clear to all of you?
Yes, yes, ma'am.
Okay. So this is all about your data cleaning, basic data cleaning, and you will get a lot of anomalies. Whenever you will get the anomalies, you have to replace it with NA, and again NA you can replace with many treatment. You can either replace it with mean, median, maximum, mode, minimum, etc., etc., or you can go for just omitting the NA values here by NA dot omit, that you can do. Okay. So like this you can do the data cleaning process. So I hope everything is clear. So in the next class we will do a lot of data manipulations, because other anomalies, to clear other anomalies you need to know a lot of other data manipulation functions. So those manipulation functions will help you not only clean the data but also analyze the data, sort the data, arrange the data, filter out the desired data, and everything. Many things can be done with data. So in the next class we will go for the data manipulations. Okay.
Okay, ma'am.
Yeah. Any doubt you are having, or anything you want to get clarified, you can ask me. Okay. So you just practice all these things. I will be sharing the material today or by tomorrow. So you just practice these things, and in the next class we'll go for the manipulation. The next phase is data manipulation.